Right now, as you watch this video, you are sitting inside a cosmic shooting gallery. The universe has been firing weapons at us for 13.8 billion years. Most of them you have never heard of. Some of them have already been fired. And a few of them you cannot escape no matter where you go, no matter what you do. This is every way the universe could kill you. And we are starting with the one that already happened. Gamma ray burst. Somewhere in the observable universe, a star is dying right now. Not slowly, not quietly. It is collapsing in on itself and releasing more energy in 10 seconds than our sun will produce in its entire 10 billion year lifetime. That energy doesn't scatter in all directions. It focuses into two narrow beams of pure radiation and fires them across the galaxy at the speed of light. We call this a gamma ray burst. And here's the part that should make you uncomfortable. You would never see it coming. The beam travels at the speed of light, which means the warning and the destruction arrive at exactly the same moment. There is no alarm, no time to react. The beam hits the atmosphere, strips away the ozone layer in seconds, and bathes everything below it in lethal ultraviolet radiation. Scientists believe a gamma ray burst, roughly 440 million years ago, may have caused one of Earth's largest mass extinctions. It already happened once, and we had no idea it was coming. But a gamma ray burst needs a dying star to fire it. The next one does not. Magnetar burst, the weapon that almost reached us. On December 27th, 2004, something 50,000 light years away, nearly ended life on Earth. A magnetar, which is a type of neutron star with a magnetic field so powerful it would erase the information from every credit card on Earth from halfway to the moon, suddenly released a burst of energy in a fraction of a second. That single burst was so powerful, it briefly ionized the upper atmosphere of Earth from 50,000 light years away. Astronomers described it as the most powerful event ever observed by humanity outside our own solar system. If that magnetar had been 10 light years away instead of 50,000, the radiation would have stripped our atmosphere completely. Every living thing on the surface would have been cooked. The closest known magnetar to Earth is about 9,000 light years away. That sounds like a lot. But space is full of objects we have not yet detected. There could be one closer. We would not know until it fired. The gamma ray burst needs a dying star. The magnetar burst needs nothing but a slight shift in its magnetic field. No warning, no prediction, just silence, and then everything stops. But at least those are external threats. The next one is already inside our solar system, and it has been building for billions of years. Solar expansion. In approximately 5 billion years, the sun will run out of hydrogen fuel at its core. When that happens, it will not simply go dark. It will expand. Slowly at first, then faster, swelling into a red giant star that will grow large enough to engulf Mercury, then Venus, and then very likely Earth itself. The oceans will boil away roughly 1 billion years before that happens, as the sun gradually brightens and raises surface temperatures beyond what liquid water can survive. Long before Earth is swallowed, it will be a scorched, airless rock orbiting inside the outer layers of a dying star. Everything that has ever lived here, every monument, every city, every record of human existence, will be vaporized without a trace. The disturbing part is not the death itself. It is the timeline. In 1 billion years, life on Earth as we know it becomes impossible. That is not a distant abstraction. In geological terms, it is uncomfortably close. The same star that made photosynthesis possible, that gave us seasons, that kept our oceans liquid, will be the thing that ends us. But that death takes billions of years. The next one can happen any Tuesday. Rogue planet. Most planets orbit a star. They have gravity keeping them in place, warmth to sustain their surfaces, a system they belong to. But some planets were ejected from their solar systems billions of years ago. Kicked out by gravitational interactions, they now drift through interstellar space with no sun, no light, no heat. Just dead rock or frozen gas giants flying silently through the galaxy at tens of thousands of kilometers per hour. We call them rogue planets. Scientists believe there may be more rogue planets in the Milky Way than there are stars. Trillions of them, drifting invisibly through the dark. Because they emit no light, we cannot detect them until they are very close. If one entered our solar system on a trajectory toward the inner planets, we might not have decades of warning. We might have years, or less. A rogue planet passing close to Earth would not even need to hit us. A near pass would be enough to distort our orbit, alter our axial tilt, trigger catastrophic tectonic activity, and send tsunamis across every continent. An actual impact would be the last thing that ever happened here. And right now, somewhere between the stars, thousands of them are moving. We just cannot see them. The rogue planet is a threat we might detect just in time to watch it coming. Vacuum decay gives us no time at all.